All right, ladies and gents, welcome back to examples 2 and 3. So if you could, go ahead, wherever you left off, you can skip a few lines and then invite yourself to example 2. Here our new polynomial written in black is 5x cubed minus 4x squared minus 11x minus 2. This is a third degree polynomial with a leading term of 5x to the third power, which I would place that little cloud around. Our second term is negative 4x squared. Our third term is negative 11x. Our first division will be with x. You know what, this time I'm going to go this way because I know I just talked about you can go in either direction. You can do whichever one first. Actually, I'm going to do this. I'm going to divide by x minus 2 on my first box, and then on my second box, I'll divide by x plus 1. All right. And then obviously that'll get us, or over time, sorry, not obviously, it's very not obvious. Over time, we will get the third linear factor. So our first linear factor, second linear factor, and third linear factor. And the first one we're going to divide by is x minus 2. Let's go ahead and set up our box. Oh, and some people might be curious, like, how do you know how many lines to put? I don't. It just so happens sometimes I get lucky and sometimes I don't. However, I do know that I always need to make space here for the two terms of the first linear factor here, x minus 2. So if this had 3 terms, then you would add another column here. I don't know how long it needs to be, so 4 I think is a good number, but you could, here, I'll go all the way over here if you really want to. I'll add another set of squares there. There's no penalty in adding more squares than you need. It's totally okay. All right. Now the leading term is 5x cubed. We're going to put it in here as the first value that represents the products on the insides, and then outsides are once again the things that we're multiplying, the items, the values that we're multiplying to get the inside values. Okay. So we need to think to ourselves, x times something gives us 5x cubed. That would be 5x squared. 5x squared times x is 5x cubed. I like to say it to myself again just to double check I didn't make a mistake. Because I'm telling you folks right now, double checking is never an issue. The worst thing that can happen here is you make a mistake and you don't catch it until the end. You have to go all the way back. And many times you're just going to have to erase all the work. So saying it over to yourself is totally okay. In fact, I would encourage it. All right, I'm going to multiply these two, negative 10x squared. Okay, 5x squared times negative 2 is negative 10x squared. Beautiful. Okay, now we need to combine these two terms here diagonally. Boop, 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 boop. Here. Okay, so this box and this box where I'm pointing need to give us this result, negative 4x squared. Now, negative 10 plus something, this is the something, we don't know what it is, needs to give us negative 4. We can solve for this by adding 10 to both sides. You guys know the deal here. It's a one-step equation. All right, so this needs to be 6x. So remember, these have to be like terms. So this is a mistake I know may happen. So if this is 10x squared and we're trying to get 4x squared, don't forget that they need to be like terms. So this also needs to be x squared. So now I'm going to rewrite this here. Negative 10x squared plus 6x squared. Did it give me negative 4x squared? It sure did. We're good. We are good. Let's keep going now. Now the outside values here, x and something, a mystery value, gives us 6x squared. That has to be 6x. I'm going to say it to myself again. X times 6x, does it give me 6x squared? Yes, it does. Over here, now we're going to multiply these two values. 6x times negative 2, that's negative 12x. Now careful here, I'm going to make a mistake on purpose, watch. I know some of us might say, oh, we just subtract them. Don't do that. They are not like terms. Remember, these right here are products of the outside values. So we multiply them. Okay, we do not add them. We do not try to subtract them. We always multiply the outside values to get the inside values. I'm going to say that to myself, 6x times negative 2, that's negative 12x. Beautiful, looking good. All right, now I'm going to draw little diagonals here to say that this square and this square needs to give us a sum of negative 11x. So I'm going to go ahead and create a new equation down here. Negative 12 plus some mystery value needs to give us this negative 11. All right, we're going to solve plus 12. Question mark. 12 minus 11, that's 1. So 1x squared. So now I made another mistake on purpose here. Negative 12x plus 1x squared. They both need to be just x. So they need to be like terms, ladies and gentlemen. I'm doing these purposeful mistakes so that you kind of don't repeat them. Okay, now I'm going to write that these diagonal values, negative 12x plus x, that it gives me, indeed, negative 11x. We're looking good there. All right, now I'm going to go ahead and hop into the outside values. So I need to think to myself, x times a mystery value gives me 1x. That's going to be 1. All right, next. 1 times negative 2 is negative 2. 1 times negative 2 is negative 2. Looking good. All right. Now, I'm going to put this little square here around the constant, which is the last term of our polynomial, and a square here, and a happy check mark there saying, hey, this worked. There's no mistake there because the last part of my calculation matches the last term of my polynomial, the constant there. All right, and then here are these extra boxes. I'm just going to erase them. I didn't need them. I'm done right there. All right, let's continue. Now, we have gotten the polynomial, which was a third degree polynomial. We have divided it by x minus 2, and we have gotten a new polynomial that is of second degree. I'm now going to put, what did I divide by first? X minus 2. This division has been completed. It is done. I don't know what's happening with that purple there. That's done. I just did that, and I'm going to draw an arrow here to tell myself that after I divided the polynomial 5x cubed by the linear factor x minus 2, this is my new polynomial that I'm going to divide over plus 1. So this is this right here. Right here. Okay. So once again, I'm going to say that again. I divided by x minus 2. That was my first division that I conducted. Here it is. And this is the result. What I got on the top is the result right here. Now, I am going to divide this polynomial right here. Again, this is the second division. I'm going to divide it by x plus 1. So I'm going to go ahead, put a little cloud around the leading term and a number 1 next to the second term, because that's going to be our diagonal value, which will be combining like terms to give us 6x. So let me go ahead and hop into it. And of course, I'll say that again when I get to it. Okay, so we got x plus 1 here on the side. And I put the leading term in here, 5x squared. I'm going to actually erase this here. I don't think that square is big enough for me. All right, 5x squared. All right, so now I need to figure out something on the outside, a mystery value. Times x gives me 5x squared. That would be 5x. X times 5x is 5x squared, looking good. 5x times 1, that's 5x. Now here comes what I was talking about, why I labeled it number 1. 5x plus something gives me 6x. And that something is going to be 1x. 5x plus 1x is 6x. So this diagonal value needs to be 1x. Okay, now I'm going to think to myself, x times something gives me 1x. That's 1. Now I'm going to multiply the outside values, 1 and 1. 1. And look at this. Isn't that beautiful there? That lets me know I'm done. And this is going to be the answer right here. That is the third linear factor which we were looking for. Now, it did ask us to rewrite the polynomial as a product of 3 linear factors. The first one being x plus 1. The second linear factor is x minus 2. And the third linear factor is 5x plus 1. All right, there we are. We're going to take a pause here. Let's see how we do.